Assalamualaikum my students, also here. The topic that we have today from differential equation is homogeneous differential equation. But before going to this very topic, we have little bit pending in variable separable method. We know the variable separable method is actually the rule that helps us to find the solution of some differential equations. Now, there is little bit pending, we will go first for that. If we have a differential equation like this, dy by dx f of ax plus by plus c. If we have differential equation like this, means beta, if we have differential equation, for example, dy by dx equal to sine of x plus y. You check here, this is actually of the form f of x plus y. F of x plus y. This kind of equation is beta, we can easily convert in such a way that our variable separable method will get hold here. So how beta, if we have this differential equation here, this type of equation, in this type of equation beta, you have to substitute here this ax plus by plus c, or here the x plus y to some other parameter. Suppose I will take here x plus y equals to z, and when you will substitute this x plus y to z, after that you have to differentiate this very thing with respect to x. So when I will differentiate here, it will be 1 plus dy by dx equals to d z. You check first here, variable separable method is not applicable. Why beta? It is, we cannot associate easily this sine x plus this dx with x, with the functions of x, and dy with y. So here it needs some special attention, and that attention is you have to put this very thing equals to z, and after that you have to differentiate this equation with respect to x. So it will be now dx, these are divided by dx. Now, which is further equal to beta? You check, dy by dx equals to dz divided by dx. We have here 1, we will transpose it to RHS, so it will be minus 1. Now beta, the final step you have to take is to make this substitution in our function, in our equation, in our differential equation, that is dy by dx. So we will substitute dy by dx as dz divided by dx minus 1. So it will be dz divided by dx minus 1 equals to sine of x plus y. I hope after here it is very easy. Sine of x plus y, but better this sine of x plus y we have taken it as z. So I hope this is understood up to here. Now better you check better here. It is dz divided by dx minus 1. Dz divided by dx minus 1 is equal to sine of z. So which implies beta, dz divided by dx equals to 1. We can transpose it to RHS, so it will be 1 plus sine. Now in RHS we have a function in terms of z, only one variable, and we have here dz divided by dx. So this is a differential equation having dependent variable as z and independent variable as x. Now we can make here variable separable method. How beta? Because we can associate this dz easily with the function 1 plus sine z, and dx we can easily separate, or we can easily associate with x. So now here you check, when we will apply here the variable separable method, so what you will get here, it is dz. We are getting here dz divided by, this will get here 1 plus sine z, and it will be equal to dx. Now we have done the variable separability here. Now after that we have to integrate on both sides. We know by the method of variable separable. So we will integrate here. It will be integral of dz divided by 1 plus sine z equals to integral of dx. Now we have to find out these two integrals. So here dz, beta here it is 1 plus sine z, it is radical here, so we will rationalize this very denominator. We will multiply both numerator and denominator by 1 minus sine z. So when it will be 1 minus sine z divided by 1 plus sine z into 1 plus sine z. You have already done a lot of examples based on this very thing. So now it is dz z equals to integral of this x dx. What is that? That is x. And now beta we can further make here. You check 1 minus sin z, that is 1 minus sin z, and you check here it is a plus b into a plus b into a minus b. Sorry, a minus b. What is that? That is a square minus b square. That is 1 square. That is 1 minus b square. That is sin square z dz equals to x. So we are getting up to here. One minus sin z divided by 1 minus sin square z dz equals to, we are getting it equal to x. Now beta, you check here, it is further equal to 1 minus sin z divided by, you check here, 1 minus sin square z. What is that equal to? That is cos square, that is cos square z dz equals to x. Now you check here, it is 1 divided by cos square z dz minus sin z divided by cos square z dz equals to x. So you check, it is further equal to 1 divided by cos, that is sec square, equals to minus integral of this sin z divided by cos z, that is tan, but 1 divided by cos again, that will be sec. So it is here sec z tan z dz equals to x. So which is further equal to integral of sec square z, that is tan z, and then minus sec square sec x tan x, that is integral of sec x tan x. What is that equal to? That is equal to sec of z and equals to x. Now after all we have to put here constant c, but we have a function in variables x and y, but we got here the solution in terms of z. So we will take this z back to our substitution. So there it will be tan of z, but z we have substituted as x plus y minus sec z, that is sec of x plus y equals to x plus c. This is our solution. So beta, it is very easy to solve the differential equation is by the method of variable separable, as you know it. Now beta, so whenever you have function dy by dx like this, you have to substitute this very thing in some parameters z or t. After that you have to differentiate and follow the same procedure that we have given here. So now you write down an example and you have to do it at your home. Write down beta. Dy by dx equals to, you write down 4x plus y plus 1 का whole square. This is again in the form of f of x plus b y plus c equals to 0. So what you have to do, you have to substitute this very thing equals to z. So you put this hint for you, 4x plus y plus 1, you take it as t or z, and now you have to integrate it with respect to x, and you will get the value of dz, you will get the value of dy by dx, and then you substitute that value in here, and after that make the variable separable method here, and you will get the solution. This is enough for variable separability method. Variable separable method. Now we will go to our actual concern, that is homogeneous differential equation. We will not take much time, but here we will try to analyze this. If we have, first of all, homogeneous differential equation, first of all we will check what actually the differential equation means, or what is the differential function, and after that we will go for differential equations. First of all we will define this homogeneity of a function in some simple function. If we have some function f of x y, f of x y equals to something, I will take it as x plus y. We call this function homogeneous. We call this function homogeneous if we will substitute this x as tx and this y as ty. X are ty. We will get the result like this. You check here, it will be tx plus ty. It is further equal to tx plus y. So that is t of f of x y. Because this way. Now if we have a function f of x y, such that this f of x y we can write as f of tx ty if we got it equal to t raised to some n f of x y. If we have a function f of x y such that the function we can get as t f of tx ty equals to this, then this function is called a homogeneous function. Why this n is called the degree of homogeneity. So here you check here, we have function x plus y, but f of tx ty we got it equal to t of f of x y. So this is clearly a homogeneous equation, but the power of t is 1, so the degree of homogeneity here is 1. So like this you can check another example. If we have f of x y equals to x square plus y, x square plus y, we have to check whether this is homogeneous or not. So what we have to do, we have to substitute this x as lambda x and this y as lambda y, or this x as tx and this y as t. So we will check here f of tx ty. So here when we will substitute this x as tx, so what it will be here, t square x square plus ty. So it is now t we can make as common, but here it is tx plus y. So it is not equal to beta t power n f of x y, because we cannot, we have here this factor of, we have this quotient of x as t here, we cannot make the common, make this t as common and get the so to get this function f of x. So we cannot get any value of n here, so that f of tx comma ty is equal to t raised to n f of xy. So this is not a homogeneous equation. Similarly, if you have now x square plus y square, it will be f of tx ty, it will be equal to tx square plus ty square. So we can make this t square as common because it is on both terms. So when we will make this, so we will get here x square plus y square. This is equal to t square x square plus y square, that is equal to f of x y. So here we got our function. So this as t square f of x y equals to f of tx t. So that means beta this is homogeneous, and the degree of homogeneity here is 2. So now you write down the definition. First one, homogeneous function. A function f of x comma y is said to be homogeneous if f of tx ty equals to t raised to n f of x y, where t is called degree of homogeneity. This is our homogeneous function. Now if we have some equation, differential equation like this, dy by dx equal to some function f of x, y, and some other function f2 of x, y. This is our function. Or if we have dy by dx equals to phi of x, y. If our differential equation is now like this and this, and if this f1xy and f2xy both are homogeneous, or if we have function differential equation that is of this form, but this phi of xy is homogeneous, then we say that this differential equation is homogeneous. For example, if we have dy by dx equals to this x square plus y square divided by x minus. If we have like this, so we have to check whether this is a homogeneous differential equation or not. What we have to do, we have to check whether this x square plus y square is homogeneous and this x minus y is homogeneous or not. If both these are homogeneous, then we say that the differential equation is homogeneous. Or if we take this as phi of xy, phi of x, y. If we take this differential equation as phi of x, y, so it will be phi of xy equals to x square plus y square divided by x minus y. Now, if this phi of xy is homogeneous function, then we say this differential equation is homogeneous. So you can check here. dy by dx, we have it equal to x square plus y square divided by x minus y. So you take it as phi of x, y. Now, if this phi of x, y is homogeneous, that means this is also homogeneous, or this whole differential equation is homogeneous. So we will check whether this phi is homogeneous or not. For that, we have a method how to get the differential equation, how to find out whether the differential equation is homogeneous or not. So we will check this phi of x, y equal to this is x square plus y square divided by x minus y. Now we will make a substitution x I tx and ty. We will get here tx square plus ty square divided by tx minus t. So it is here now. You check here t square is here and associated with x and as well as this with this y. So we can make this t square as common. So it will be t square and then x square plus y square. But in the denominator there is again t x and minus ty. So t is in both terms, t here and in this term. So we can make this tx as common, t as common. So t x minus y. So it is now t and t square will get cancelled. So we are getting here t x square plus y square divided by x minus y. X square plus y square divided by x minus y. That is f of x y. That is f of x. So if we analyze this very thing, what we have done, so you clearly check we are getting here this phi of x as homogeneous function with the degree of homogeneity equals to t raised by 1. That is homogeneous degree is 1. So now when this is phi of x and phi of xy is what we call homogeneous, then this whole differential equation is homogeneous. So you write down the definition. A differential equation dy by dx equals to phi of xy is said to be homogeneous differential equation if phi of dx dy equals to t of tn phi of x y. So this is easy. Now you write down some examples and after that we will conclude. And tomorrow we will get the method that will help us to find out the solution of those equations which are homogeneous. So you write down the first example. Check whether whether the following are homogeneous or not. First one, dy divided by dx equals to x square minus xy divided by x plus x square plus xy square plus xy. This thing. Another example, you take as dy by dx or x dy by dx equals to minus y square divided by x. This is your another example. And the third one you take as dy by dx y square equals to 5x 5x, yes, this 5x plus, no, but just 5x. So these are the three differential equations. You have to check whether these are. No, you take another example. 5x plus 1 dy by dx equals to x square plus 1. This is another example, and you have to check whether this is homogeneous or not. So it is enough for today. Inshallah Rahman, tomorrow we will go for the rule of this homogeneous differential equation to find out the solution of that very equation. So now it's enough.